Continuing with the review, problems 14 through 16, the instructions are to graph. We'll be sketching the graph. We want to highlight asymptotes. Okay, f of x equals 5x over x plus 1. Get that equal sign out of the way where it belongs. All right, for this, the degree of the numerator and degree of denominator are the same. Therefore, the horizontal asymptote will be leading coefficients 5 over 1. Horizontal asymptote equals 5 over 1. It's going to be the y. Y equals 5. And vertical asymptote, we get that from restrictions on denominator of x plus 1. Let's look at x plus 1 equals 0. X equals negative 1. That's going to be the vertical asymptote. Okay, the 5 represents a vertical stretch of 5. Let's plot a couple of points on each side. X equals 0. It's a little low. What's wrong? For x equals 0, f of x will be 0 over 1. So one of our points is 0, 0. Now, for x equals 1, we'll have 5 over 2. For x equals 2, we'll have 10 over 3. See what's happening in this section? Getting closer to the horizontal asymptote as x increases. And we get closer to the vertical asymptote as x gets close to negative 1. All right, let's put in a negative 2. We'll get negative 10 over negative 1. So for negative 2, we'll be at the point 10. And we know that we can conclude it goes up towards infinity, getting closer to negative 1 from the left, and it comes down towards the horizontal asymptote, y equals 5, as x goes towards negative infinity. All right, that's number 14. Number 15, sketching a graph. Sometimes I write the function first, sometimes set up the graph first. And let's find a spot to get this function in. F of x, it's going to work. X squared plus 5x minus 6 all over x minus 1. That's going to factor to x minus 1 times x plus 6 over x minus 1. All right, we have x minus 1 canceling, so the discontinuity or whole is that x equals 1. We'll get that actual point by evaluating the simplified function x plus 6 at x equals 1. So 1 comma 7 is the location of the whole. Now, there is no vertical asymptote. Since there is no denominator, This function simplifies to the linear function x plus 6. So we have an intercept, let's go with blue, y-intercept at x equals 6. And we have a linear function, slope of 1. And again, the whole is at 1, 7. All right, that's number 15. Number 16, sketch a graph. Sorry, looks like that was number 16. Okay. Next set, number 17. Determine the equations of any vertical asymptotes and the values of x for any holes in the graph, which I will write. Function. Make it a little more visible. X squared minus 2x minus 35 in the denominator, x plus 5 in the numerator. We need to factor the denominator into two binomials, x minus 7 and x plus 5. Since x plus 5 and x plus 5 cancel, that's the discontinuity or the whole at x equals negative 5. From x plus 5, we get x equals negative 5 for the whole. Now it will be located at the point negative 5. Evaluating at negative 5, what remains? It's going to be a 1. 1 over x minus 7, so that's going to be 1 over negative 12, which is negative 1 over 12. Is the way you'll see it. All right, so we took care of the whole vertical asymptote. We still have x minus 7 in the denominator. That will be 0 at x equals 7. And that takes care of number 17. Okay, number 18. Determine the equations of any oblique asymptotes in the graph of the function. Let's write the function. F of x equals numerator of x squared plus x minus 5 and denominator of x plus 3. All right, oblique asymptotes occur if the degree of the numerator is 1 greater than the degree of the denominator, and that is the case 2 compared to 1. So I'll use long division. X plus 3 is the divisor. X squared plus x minus 5 as the dividend. So the multiplication. I'll be careful to subtract, distributing the negative sign. Yield negative 2x minus 5, and that will give a negative 2 over negative 2x minus 6. Subtract carefully, and this part is unimportant. Negative 5 plus 6 is 1. The remainder does not matter. Here's our oblique asymptote, also known as slant asymptote. The y equals x minus 2 is the line. All right, that was number 18. Hoping my face or head does not appear in the video. Quite a distraction. But if it does, I'm not going to edit out this time. Okay. Number 19 through 24, the remainder of the test will be problems that you solve. So 19, I'll rewrite it each time. It'll 1 over x plus 4 equals 6 minus x divided by x plus 4. Have an equation, rational expressions. Let's get this over x plus 4 by multiplying numerator and denominator by x plus 4. Now, x plus 4 is in the denominator. X cannot equal negative 4. We've dealt with the restriction. We only need to focus on the numerator. We have negative 1 equals 6x plus 24 minus x. So negative 1 equals 6x, 5x, finding like terms, plus 24. 5x equals negative 25. So x equals negative 5, which is not restricted. It becomes the answer. Moving on to number 20. One third equals 5 divided by m. 5 needs to be a 5. Plus 3 plus 8 divided by 21. Dealing with restrictions, m cannot equal negative 3. Now let's get common denominators. We need m times, or m plus 3 here, and we need m plus 3 here. Numerator needs m plus 3. Numerator needs to factor m plus 3. 21 is 3 times 7. So we still need a 7 as a factor here. And this needs 21. Good to go. We don't have to consider denominator because we know that the restriction is m equals negative 3. So 7 times m, 7 times 3 equals 105. We're multiplying 5 times 21. And that's going to be plus 8m plus 24. All right, so we'll have an m on the left after subtracting 7m, and 109 subtracted give us negative 88. That's 129. That will give us negative 108. Okay. That will take care of number 20. Now, number 21 of 24 problems. Seven plus 2, which is divided by x, is less than negative 5 divided by x. And x cannot equal 0 in this inequality. Multiply the first term by x divided by x. Now we have common denominators. X gives us 7x plus 2 is less than negative 5. 7x is less than negative 7. X is less than negative 1. Let's look at an alternative method of solving this. Subtract 2 over x from each side. 7 will be less than negative 7 divided by x. Again, you still have x does not equal 0. Multiply both sides by 7. Multiply both sides by x and divide both sides by 7. We will have x is less than negative 7 over 7. X less than negative 1. And the restriction does not come into play because being less than negative 1 will not include 0. Last sheet for 22 through 24. Here we go. Solve each equation. R plus 6 divided by R minus 5 equals 0. R in the denominator, so R cannot equal 0. Multiply the first term times R divided by R to get R in the denominator. Multiply this term, R divided by R, and even over here with the 0. Might not have a 0 over there, so you don't want to forget about it. Okay, denominators will be the same. We can disregard them because the restriction is accounted for. This is R squared plus 6 minus 5R equals 0. Rewriting R squared minus 5R plus 6 equals 0. Factoring into two trinomials, R minus 3, R minus 2 equals 0. Using the zero product property, R equals 3 from that factor, R equals 2 from that factor. Each of those solutions is acceptable. After consideration for the restriction, we're good to go. Okay, number 23. Six divided by 7 minus 3m divided by 2m minus 1 equals 11 over 7. Rational equation. Subtraction. We need common denominators. This one will only need 7. This one will need the 2m minus 1, 2m minus 1, 2m minus 1, and 2m minus 1. Hope you can work sideways or at a slant. All right, what's restricted? Don't want to forget about the restriction. 2m minus 1 equals 0. That's going to simplify after a couple of steps, so m cannot equal 1/2. Otherwise, we're good to go with our solutions. Solution or solutions. Now, we only need to consider numerators. Distribute the 6. 12m minus 6. We have 21m which needs to be subtracted, equals 22m minus 11. This side we have a negative 9m. When we add 9m, that will bring us to 31m. When we add 11m, or 11, that will equal 5. So m equals 5 over 31. It's a unique answer, so I'll quickly double check. It's good we haven't double checked today. Always good to double check. Denominators each have 7 times 2m minus 1 as factors. We had 12m minus 6 minus 21m, 22m minus 11, 12m minus 21 is negative 9m. Add it, that will be 31m. And adding 11, so everything looks good. Alrighty, final problem 24. And this value was not restricted. 1/2 was restricted. R plus 2, 3r in denominator, r plus 4 plus r minus 2 in denominator, minus 2/3. Okay, let's get common denominators after we check for restrictions. R cannot equal 0, r cannot equal 2. Have the 3, we have the 3. Let's multiply this by 3. And we'll need to do it in the numerator. Now we have r, so we need to multiply this by r. We need to multiply that by r. We need to do it in the numerator and in the numerator. Last factor is r minus 2. Needs to be common for each denominator. Okay, denominators are the same, restrictions are accounted for. Focus on the numerator. R plus 2 times r minus 2 is r squared minus 4. That's going to equal 3r times r plus 4. Let's write it up here. 3r times r plus 4. Distribute 3r. 3r squared plus 12r minus 2r times r minus 2. Set the brackets up to ensure that the negative sign is distributed. So that's going to be 2r squared minus 4r. Okay, let's simplify everything. First, distributing the negative sign, minus 2r squared plus 4r. Everything else can be brought down left to right. R squared minus 4 equals 3r squared plus 12r. 3r squared minus 2r squared is r squared. So r squareds will cancel because you have r squared on the left and right. You have 16r on the left equals negative 4. R equals negative 1/4. All right, check that problem out. Let me know if I made any mistakes. Let me know what questions, comments, concerns you have. Thank you for watching.